Our brains don't think so well in logarithms. We don't have a log on each side, so we can't use the one-to-one property of logarithms, but we could rewrite this as an exponential equation and solve it. So we've got our base 2 to what power?
4.
To the 4th equals the quantity x minus 1. So we can just solve this. 2 to the 4th, 2 times 2 times 2 times 2, 16. Equals x minus 1. So how to remove a subtraction of 1?
Plus 1.
Add 1. So we've got x equals 17. So we got to make sure we can use that answer. So remember, in a logarithmic function, the domain is 0 to infinity, so this quantity here has to be greater than 0. If I replace with 17, that makes it 16, we're good. So we keep that answer. That was worth 3 points. 9b. 9b is worth 4 points. So we've got ln2 equals lnx plus lnx plus 1. So we do have logarithms, natural logarithm, log base e on both sides. So we'll be able to use the one-to-one property, but first we want to get one logarithm on each side. So we're going to take two separate logarithms, same base of e, with addition, combine them to be multiplication. So we have ln2 equals ln of x times x plus 1. And so now, since we have the same logarithm on each side, log base e, we can use the one-to-one property and set the quantities equal to each other. So we've got 2 equals, and I'll distribute x squared plus x. So there's a good old quadratic equation, which should factor as long as we make one side 0. If it didn't factor, we'd use the quadratic formula or some other property, but I made it so it factored. So I'm going to subtract 2 from both sides. 0 equals x squared plus x minus 2. Again, factoring is your friend. Easy way to go. So I'm going to factor that. First times first, x times x. Last sign's minus, so the signs are different in the factors. Factors of 2 are 1 and 2. I want plus x, so I'm going to put a plus on the 2 and a minus on the 1. So to finish, I'm going to set each factor equal to 0 and solve. So here I'm going to subtract 2. So one possible solution for x is negative 2. Here I'm going to add 1. And I'm going to get x equals 1. Now remember, we have to go back and check. In a logarithm, the domain is 0 to infinity. So that means all the quantities have to be positive. So can I put negative 2 in for x here and here? No, because it's not defined in the domain, which is 0 to infinity. So we cannot use negative 2. We have to reject that. It's not defined in the domain of a logarithm. But 1 is fine. If we put 1 here and we put 1 here, that works. So x equals 1 is my solution. Okay, so 9c. We have, we're 3 points. 3 to the x minus 2 property, equals 1/9. 3 to the x minus 2 equals 1/9. So, 1/9 is a power of 3. So we could just use the one-to-one property and make life easier on ourselves. There are harder ways to do it, but let's go the easy way. So let's make 9 as a power of 3. So we'll have 3 to the x minus 2 equals 3 to the what power? Negative 2, right. You have to square it and invert it. So now we can just use the one-to-one property for exponential functions and set the exponents equal to each other since they have the same base. And solve x minus 2 equals negative 2, adding 2. We get x equals 0. This is fine. Remember, in an exponential function, the domain is all real numbers, so it's fine to have use 0. That's fine, and it checks. So again, in the bottom right-hand corner is your total that you missed on page 2. Going over to the other board for page 3, number 10. So number 10 is worth 6 points. A lot to do in number 10. Given f of x equals the log inverse of x. So, my base here is what on this logarithm? 10. So the inverse of a logarithmic function would be an exponential function with base 10. And so first thing we do is replace f of x with y equals log of x minus 1 plus 3. The next thing we're going to do is we're going to switch and solve. So we're going to switch x and y in the equation and say x equals log of y minus 1 plus 3. So now we want to do everything we can to solve for y, to get y by itself. So I'm going to remove the addition of 3 by doing what? Subtracting 3 from both sides. So I have x minus 3 equals the log of y minus 1. So at this point, we've gone as far as we can with the logarithm. So we can't really go any farther to get y by itself, so we're going to change to an exponential function, to the alternate format. Once you're stuck, go to the other format. So my base here is 10, so we're going to take 10 to the power x minus 3 equals the quantity y minus 1. You could say y minus 1 equals 10 to x minus 3 power. And so again, I want to get y by itself, so remove a subtraction of 1, I'm going to add 1 to both sides. So I've got 10 to the x minus 3 plus 1, maybe you put the 1 out front, equals y. And so the last step is to replace y with f inverse of x. So that's what we're asking for, technicality here. So 10 to the x minus 3 plus 1 equals f inverse of x. And that was for 6 points. Number 11. 11a, worth 4 points, says, use a calculator to find the approximate answer rounded to 4 decimal places for each equation. So we have 3 to the x equals 34. So there are 2 different ways to do this, and I'll show you both ways. Either way gives you about the same number of steps here. And so, by the way, 34 is not a power of 3, so we can't do it the easy way with the one-to-one properties. So one way to do this is to just change it to logarithmic form from exponential form. So we could say the log base 3 of 34 equals our exponent x. That's one way to do it. And so we can't put log base 3 of 34 very easily into our calculator unless you have a graphing calculator, which you can actually. But if you don't have a graphing calculator, you can go to the base change formula. So the base change formula says this is the log of 34 divided by the log of 3 equals x. So we can just put that into our friend the calculator. It says round to 4 decimal places, and so you're going to get 3.2098 approximately equals x, which should make sense because 3 to the 3rd power is 27, so it would be something a little bit more than to the 3rd power of 3 to get 34. So that's one way to do it. The other way to do this same problem is to do the same thing to both sides, which is either to take the log, the common log, or the natural log, ln. Either one, because those keys are on your calculator, and you'll get the same answer, maybe one extra step. So if I take the log of each side, and I'm allowed to do that because it's an equation, so I have the log of 3 to the x equals the log of 34. Then I would use the power rule, and I'd have x times the log of 3 equals the log of 34. To remove multiplication, you do division. So I'm going to divide both sides by the log of 3. And cancel. And again, putting that into your calculator, rounding to 4 decimal places, it's about 3.2098. Rounded to 4 decimal places. That's worth 4 points. All right. I guess somebody should get up and switch the camera because I'm going to the other board. Can somebody gradually move the camera to the front? Since our camera person left us. Maybe, yeah, just more. Yes, that's good. Thanks. Hopefully I don't have to run my own camera here, right? Can you see me from here?
Yeah.
Okay, good, thank you. That's like my husband, the television reporter, has to shoot, edit, right, post to the web, has to do everything himself. I'll have to tell him that I have to run my own camera, like he does. All right, so 11B. This one is worth 5 points, lots of steps on this one. So we have 5 to the x plus 1 equals 20, and we want to solve and get an approximate answer for x, rounded to 4 decimal places. Okay, so 20 to the x, thank you. Thanks. Okay, so what we're gonna do is 20 is not a power of 5. So what we're gonna do is we're gonna do the same thing to both sides, which is either to take the log or the natural log, either one. So I'll do the log, generally students prefer that, but you could also do ln. So the log of the left side equals the log of the right side. Again, you're allowed to do this because you're doing the same thing to both sides. So we have the log of 5 to the x plus 1 equals the log of 20 to the x. So now we're gonna use the power rule. So we're gonna put the power up front, so x plus 1 times the log of 5 equals x times the log of 20. Okay, so we have to distribute the log of 5 to each of those. So x times the log of 5 plus 1 times the log of 5 equals x times the log of 20. So now we want to get all the x's on the same side. And so we're going to subtract x times the log of 5, so all the x's are on the same side. So we're going to subtract x times the log of 5. So I've got log of 5, I don't really need the 1, equals x times the log of 20 minus x times the log of 5. So that all the x's are on the same side. We also, when we're solving for x, would only like one x to appear in the equation, so we're going to